Hi, I'm Jared. Welcome to Fun Science Demos. Check this out. How did I do that? What was going on there? Was it magic? No, it was science. Well, what you didn't see me do was rub this straw on this fur and charge it up. Well, what do I mean when I say charge it up? Well, through science, we've discovered that all matter is made of positive and negative charges. And sometimes, some of that matter, we can actually rub off only the negative charges. And that allows us to do some really interesting things. Remember, by me rubbing this straw on this fur, I'm putting more negative charges on the straw. And through science, we've discovered that positive and negative charges attract. They come together. Think of it like this. When the charges are different, they want to come together. But when the charges are the same, they want to push apart. And scientists call that static electricity. So now let's take a look at this. So I have a can, and remember we said that all matter is made of positive and negative charges. This can is not charged, so it's made of positive and negative charges. Now watch what I do here. I'm going to rub this balloon on the same fur that I rubbed the straw on, and it's going to pick up a whole lot of extra negative charges. What do you think is going to happen when I take this balloon and put it toward the can? Will the can push away, or will the can roll toward the balloon? Let's take a look and find out. Here we go. Negative charges on the balloon. The can is made of positive and negative charges. What just happened there? The positive charges on this can were attracted to the lots of negative charges on this balloon. Let's see if we can do that again and see how fast we can get this can going, maybe race it off the table. Can races with static electricity. So remember we said all matter is made of positive and negative charges, and that also holds true for liquid matter. Here I have a container of water and I have a cup with a hole punched in the bottom. I'm going to fill this cup with water, hold it up and let the water drip out the bottom of the cup, and then hold my balloon up to that stream of water. Let's see what happens. Is the water going to be pushed away from the balloon, or is it going to be pulled toward the balloon? So now I'm going to rub the balloon and charge it up with lots of negative charges. Hold up my cup, and you can see the water is pulled toward the balloon. So what does that mean? Well, I had a lot of extra negative charges on here. What kind of charges attract? Well, opposite charges attract. So that means this water must have lots of positive charges. So what does that mean? That means as I rub the balloon on the fur and I charge it with lots of extra negative charges, if that water is pulled toward the balloon, that water must have positive charges in it. So we know that balloons can pick up extra negative charges, but I have to wonder, can other things pick up extra negative charges? So to test this out, we have lines of just torn up little paper called confetti. I have a comb, a plastic fork, and a plastic bat. And instead of using fur, we're going to try using wool, just wool fabric. So let's check it out. Let's start with the comb. Pick the comb up. I'm going to rub the comb on the wool, charging it up with extra negative charges. What do you think is going to happen when I pass it over the torn up pieces of paper? It's kind of jumping onto the comb, but is it really jumping? No. Positive and negative charges attract. It worked okay. Let's try the fork. Charge it up with lots of extra negative charges. Pass the fork over. And you can see a few bits of paper are attracted to the negative charges. Now let's try the plastic bat. We charge it up, and you can actually hear and see the paper stand on end as I wave it over, and it jumps right onto the bat. It didn't jump. The positive and negative charges were attracted to each other. So finally, take a look at this game that we made up using static electricity. We call it Sharks and Minnows. I have some sharks made of tissue paper hanging from this crate. You could hang them from your desk and let them drape down toward the floor. And then I have a little dish of what I call fish food. It's just the confetti we used in the other demonstration. And then I took the straw we used from the very beginning. I cut out a little styrofoam fish. I taped 2 straws together. Here's the minnow, here are the sharks, and this is how it works. The fish food goes in here. The idea is you have to charge up the minnow straw, getting lots of extra negative charges on this. And I have to try to get some of the food to be attracted to the minnow without getting eaten by the sharks. As soon as the sharks touch the minnow, I'm out. So let's see if we can do this and reach in. He got me. Let's try over here. He got me. Reach in this way. Static electricity. Could actually be a fun game. Sharks and Minnows. Sharks and Minnows was a game we created using static electricity. Can you create your own game using static electricity? What if instead of tissue paper sharks, what if I hung up soda cans? I don't know, give it a try. Science is so cool. If you want to learn more about static electricity, check out our links in the video description. Thanks for watching.